So tonight's video is going to focus on G-forces and center of gravity, which has to do with our first learning target in our third unit. And our first learning target is still analyzing the differences between mass and weight. And the first thing I need you to do is take out your blue unit organizer, and in slot 6 you're going to write in G-force and center of gravity notes. And as usual, note sheets are no score. So on this note sheet, you're going to mark page number 6. And the first thing we're going to talk about are G-forces. And G-force is just a really nice way of saying gravitational force. And a G-force is the combination of forces acting on an object. And when you think about G-forces, the first thing you should think about is a roller coaster drop. So when you're on a roller coaster and you're going downhill really quickly, sometimes it feels like your stomach is up in your throat, and that's the G-forces affecting your body. So say someone's experiencing 0 G's worth of force. That means they're not experiencing any gravitational force whatsoever. So that means they would be weightless. So that would be kind of like in space. If someone's experiencing 1 G worth of force, that means they're experiencing normal gravitational pull. So just how you feel right now, you're experiencing 1 G worth of force. Instead of 2 G, we're going to talk about 3 G's. And if you're experiencing 3 G's worth of force, that's like being on a space shuttle launch. And if you think about it, if you watch movies and there's some space shuttle launches in there, you see that these actors are holding on to their seats for dear life, and their faces are going backwards, and they're holding their breath. And that's how it would feel. There are 3 G's, or 3 times the gravity's worth of force acting on their body. Instead of 3 G's, we're going to talk about 4 G's. So at 4 G's is when people start to get nauseous and they start vomiting or throwing up. Now, 2 examples we're going to talk about when we think about G-forces are a roller coaster ride and then deadly forces, because G-forces are deadly. Now, for a roller coaster ride, typically high G roller coasters range from 3.5 G's, so 3.5 times the gravity force acting on your body, to 6.3 G's worth of force. So if you know someone who throws up on roller coasters a lot, they should either A, pick a different roller coaster, or B, try to get used to the G-forces that are acting on them, because this range is above that nauseous and vomiting level. Now, G-forces can be deadly, and typically they go from 16 G's to 50 G's. That's a really big range, but it depends on the length of your exposure. So being exposed to 16 G's for a long time is like being exposed to 50 G's for a very short time. Now I have this guy, and as an example, we got introduced to John Stapp in the car design video we watched earlier this year in class. Now, John Stapp was a pioneer in car safety designs. He experienced a force that was close to having his body almost being weighed around 4,700 pounds. If you'd like more information about that, I put the link to the article underneath this video. The next thing we're going to talk about is center of gravity. And center of gravity is the point at which all the weight of an object is centered. And there are 2 variables that influence that stability of an object. The first is the position or height of the center of gravity. Now in men, the center of gravity is in their chest area, and for women, it's in our hips. Well, it turns out the lower to the ground that your center of gravity is, the more stable you are. So technically, women should be less klutzy than men, and we all know I put that to shame. The second variable that influences the stability of the object is area of support, or how wide your center of gravity is. So if you have more area, or it's wider, that means you're going to be more stable. Now let's talk about 2 real-life examples for center of gravity. Our first one's a sumo wrestler, and I really like that picture. I think it's pretty funny. Now a sumo wrestler, when he starts competing, or any wrestler for that matter, will crouch down, which means he's going to lower the position of his center of gravity. He's also going to widen his stance, which increases his area of support.
Sabrina Guyton to Miss Caesar's room. Sabrina Guyton to Mrs. Caesar's room.
This helps him be the most stable. So not only is he, widening his area of support by widening his stance, but he's also crouching down, which is lowering his position. So he's taking into account both variables that influence his stability. The second thing we're going to look at are car engines. And a car engine is always going to be in the front of your car. A long time ago, they used to be in the trunk on old Volkswagens, and that wasn't a good idea, and here's why. A car engine is in the front of the car, and is close to the ground. So that means it has a lower position, and engines are really big. They have a large area of support. This helps make the car more stable. So when car engines used to be in the trunk area or in the back of the car, cars were more apt to turn over rather than if they were in the front of the car, which helps cars not only be more fuel efficient because they're helping them go forward. Remember, an object in motion wants to stay in motion. If you have more mass in the front of the car, that'll help you be more efficient in your motion. But it also helps the car be more stable because it's able to be lower to the ground and closer to where the most power needs to be.